A curve with the equation y equals the function of x is such that f dash x, which of course means the derivative, is equal to 2x to the minus a third minus x to the 1/3. It is given that f8 equals 5. That means when x is 8, y is 5. Find the function of x. To find the function of x, we need to integrate the derivative. So we're going to start with the function of x is equal to the integral of 2x to the minus a third minus x to the 1/3 with respect to x. Right, to integrate, we look at the variable and we add 1 to the power. The power is negative third, we add 1, we will get 2/3. And that 2/3 needs to be cancelled. If we were differentiating, the 2/3 would come out the front, but there is no 2/3 out the front. So we're going to multiply by the reciprocal, which is 3/2, to cancel it. For the next variable, the x to the 1/3 would have come from 4/3. And we have to do the same thing. We have to cancel the 4/3 that would come out. And so we multiply by the reciprocal, which is 3/4. Add the constant, and we're finished. We can clean this up a little bit. 3/2 times 2 is just 3, so we'll have 3x to the 2/3 minus 3/4 of x to the 4/3 plus c. That's our function. But we need to, of course, find what the value of c is, and we use the information that when x is 8, y is 5, and so we're going to say that 5 is equal to 3 times 8 to the 2/3. Right, 2/3 means we're going to do the cube root of 8, and then we're going to square it. 3/4 of 8 to the 4/3, cube root of 8 to the power 4, and plus c. So we have 5 is equal to, the cube root of 8, as we said, is 2, 2 squared is 4, and 4 3s are 12. So we'll have 12, and we're going to subtract. The cube root of 8 is again 2, 2 to the power of 4 is 16, and so we've got 3/4 of 16. 1/4 of 16 is 4, times it by 3, and you get 12. And of course we add c. Well, 12 minus 12 is 0, and so what that tells us is the variable c is equal to 5. So we found the function now. The function of x is equal to 3x to the 2/3 minus 3/4 x to the 4/3 plus 5. A curve has the equation y equals x squared plus 2cx plus 4, and a straight line has the equation y equals 4x plus c. C is a constant. Find the set of values of c for which the curve and the line intersect at two distinct points. Right, because we're trying to find when they intersect, we're going to treat these two functions and say, how would we normally find intersection points? Well, we're going to say, well, the y values must be the same. And so we will say that the straight line for x plus c, which is, of course, the y value, is going to equal the y value from the other equation, which is x squared plus 2cx plus 4. Okay, we've got a quadratic. We just have to get everything onto the same side. So let's move everything to the right, and we'll put it on the left. So we have x squared plus 2c minus 4. Of course, we would take the 4x over and subtract it. Of course, it's with the x. And then we also have plus, I'm going to put it in brackets, 4 minus c. And the reason I put in brackets is because now you can see the quadratic, and of course that equals 0. You can see the quadratic parts where the coefficients a is 1, b is 2, c minus 4, and the c is the 4 minus c in terms of the generic form of a quadratic. Okay, what we do know from the question is that it intersects at two distinct points, and for that to happen, this quadratic has to have two x values. There has to be two answers. And for the quadratic to have two answers, we know that b squared minus 4ac, the discriminant has got to be greater than 0. If it is greater than 0, then there are going to be two solutions for the quadratic. So we use that to find out what the two answers are going to be. B is 2c minus 4, so we're going to square it, and we're going to subtract 4 times a is just 1, so we're going to have 4 times 4 minus c, and that of course is now greater than 0. So we need to expand the brackets. We have the form of a plus b squared, which is a squared plus 2ab plus b squared. So a is 2c, we square it, and we're going to get 4c squared, plus 2ab is 2 times 2 times negative 4, which is negative 16 times c, and b squared is negative 4 squared, turns into positive 16. Expanding the other brackets, negative 4 times 4 is minus 16, and negative 4 times negative c is plus 4c. And this, of course, is still greater than 0. So we collect like terms. 16 minus 16 cancels out to 0. Negative 16 plus 4c turns into negative 12. So we have 4c squared minus 12c is greater than 0. Right, this is a quadratic. And we're asking the question, when is the quadratic greater than 0? When is the, you could think y value, when is it going to be greater than 0? When is the quadratic above the x-axis? Right, to do that, it's really handy to find the roots. So we should factorize this and find out what the roots are. We will take out 4c, and we're left with c minus 3, and that's still saying the quadratic is greater than 0. So this quadratic, which is based in the variable c, if we were to sketch it, we would know the roots are at 0 and 3, 3 and 0. And what sort of quadratic is it? Well, if you look at what's in front of the squared term, it's a positive 4, so that means it's a smiley quadratic. In other words, it's going to look like this. And if we did that, we could say, well, we know exactly when the quadratic is greater than 0. It's when, of course, you're above the x-axis. That's when the result, or the y value for the quadratic is greater than 0. And for that to happen, x is going to be less than 0, or x is going to be greater than 3. Of course, we're not dealing with x's in this case, we're dealing with c's. But that is the answer for us. C is going to be less than 0, or c is going to be greater than 3. Question 3 is find the term independent of x in each of the following expansions. The first one is in brackets 3x plus 2 over x squared to the power of 6. So you have to remember how to do a binomial expansion and then find the term they're talking about. Well, a term which is independent of x means that that term doesn't have an x. Independent of x means it exists without an x. And so we're looking for a term that doesn't have an x value in it. And so just have a think again, how do you do a binomial expansion? 3x plus 2 on x squared to the power of 6 is equal to, we're going to do 6c0 combinations, of course, and 3x in brackets raised to the power of 6, and 2 on x squared to the power of 0, but we don't write that. Plus 6c1, 3x in brackets to the power of 5, 2x squared to the power of 1, and notice the powers add to 6, 5 and 1, 6 and 0. And then the third term would be 6c2, 3x to the power of 4, 2 over x squared, and on it goes. All right, so hopefully you can see the term that we want is on the screen now. You're looking for where the eventual powers of x are going to cancel out. And so the 3x to the 4 will produce x to the 4, and the 2 over x squared is going to produce x to the 4, which is on the denominator, x to the 4 on the numerator, divided by x to the 4 on the denominator. They cancel out, and there is no x term. Right, so that's the term that we're looking for. If you could do that in your head, you don't need to write all of that. I think you can get away with doing this. 3x, we certainly need to explain what we're doing. 2x squared to the power of 6 is equal to, and you can write ... because there's a lot of things, and then we're going to add 6c2. We're using the bracket notation for that, and then we're going to take 3x to the 4, and we're going to take 2 over x squared and raise it to the power of 2. We should put a plus and ... Of course, there are other terms involved here. Right, so the term that we're just interested in is right before us, and we're just trying to work out what each part is. All right, 6C2, you can use your calculator to work that out. If you don't have a calculator, you could draw Pascal's triangle, or you could use the definition of 6 factorial, 2 factorial, 4 factorial, work out what that is. We'll work that out. And then we have 3 to the power of 4, which is 81. 3 squared is 9, 9 nines are 81. And we have x to the 4. We don't need to write it. We may as well. X to the 4. And when we're going to square, we're going to have 2 squared, which is, of course, 4 over x to the 4, because it's x squared to the raised to the power of 2. We multiply the powers. And maybe to be very clear, we should indicate this is just the term that we're interested in. All right, the 6C2, 6 factorial divided by 4 factorial is fairly easy to work out. 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. 4 factorial is 4 times 3 times 2 times 1. And so the 4 factorial cancels out a lot of the 6 factorial, and you're only left with 6 times 5. 2 factorial, 2 times 1 is just 2, and you can divide 2 into 6 and get 3, and so we just have 3 times 5, which is 15 for 6C2. Then we're going to multiply that by 81, and the x to the 4 cancels with the x to the 4, and we're left with 81 times 4. Put it into a calculator, and you'll get 4860, and so 4860, this is the term that is independent of x. For the second part of the question, we need to have just a little think about what's happening, because we have to find the terms that are independent of x again. Hopefully you notice that the first brackets, the 3x plus is what we just expanded, or we just found one term from that expansion to the 6. But this time we're multiplying that expansion by 1 minus x to the 3. Okay, and what happens with that? Well, every term in here is going to multiply. The 1's going to multiply by all the terms in that expansion, and the x cubed is going to multiply all the terms in the expansion. And we have to work out, well, is that going to produce terms without an x? Well, of course, the 1 is going to multiply by a constant to produce a term without an x. We already know what that constant is. What we have to think about is, does the x cubed multiply by any of the expanded terms, and is going to cancel out the x from that term? Well, what we're interested now in is, does the 3x plus 2 on x squared to the 6 produce a term with x to the negative 3, or 1 over x cubed? Because if it does, then x cubed multiplied by that term is going to cancel the x's out, and we will just have a term independent of x. That's what we're looking for. So to help us with that, we need to consider the previous expansion that we were looking at. Okay, so if we had done the previous expansion, it would be hugely beneficial. If we hadn't done, we just need to consider what powers of x get generated. And from the first term, we have a power x to the 6. From the second term, we would have x to the 5 divided by x squared is x cubed. From the third term, we have x to the 4 over x to the 4, which is x to the 0. And hopefully you see a pattern there, and that pattern would continue, where every term is producing an x of 3 less than the term before it. Right, but this gives us an answer that we're looking for. We're looking for a term with x to the negative 3. So the term that's going to produce the x with the negative 3 is the next one that we haven't done. We'll work it out. It's going to be 6 to the 3, and we'll have 3x to the 3, and 2 over x squared to the 3 as well. And that's going to get multiplied by the negative x to the power of 3, and the 3's would cancel. Right, so when we try to work this out, we will get 63 is 6 factorial over 3 factorial, 3 factorial, and 3 cubed is 27, x cubed, and 2 cubed is 8, over x to the 2 3's are 6, That produces our -3. All right, simplifying this term, 6 factorial over 3 factorial. The 3 factorial would cancel out 3 by 2 by 1, leaving 6 by 5 by 4. The other 3 factorial is 3 by 2, which is 6, which would cancel out the 6, leaving 5 by 4. And so, if you thought like that, that turns into 20. We're going to, of course, multiply it by 27. It's still there. X to the cube cancels with x to the 6, and we're going to be left with 8 over x to the 3, or x to the -3 if it went to the numerator. All right, I'm using a calculator now, and I'll get 4320, and let's just say x to the -3. Okay, so the expansion that we're interested in is when we take all the terms, well, it's just 2 terms, which are going to be 4a60 from our previous expansion multiplied by the 1 on the 1 minus x to the cubed, and we're going to add to it the other term, which is 4320 x to the -3. We're going to multiply that by -x cubed, because the x cubed is going to cancel with the x to the -3. But that minus sign on the x cubed stays there, and so our answer is actually 4860 minus 4320, which is 540. The first term of a GP and the first term of an AP are both equal to A. Makes sense. The third term of the GP is equal to the second term of the AP, and the fifth term of the GP is equal to the sixth term of the AP. Given that the terms are all positive and not all equal, find the sum of the first 20 terms of the AP in terms of A. All right, so we're going to have to create some equations and find the sum in terms of A. Let's do that. The third term of the GP is AR to the n minus 1. N is 3. Minus 1 you get 2, and so it's AR squared. And that's going to equal the second term of the AP, which is A plus n minus 1D. Again, second term, 2 minus 1, it's just going to be A plus D. The fifth term of the GP, likewise, is going to be AR to the 4, plus we get 5 minus 1, and that's going to equal the sixth term of the AP, so it's going to be A plus 5D. Because ultimately we're trying to find the sum of the AP in terms of A, we know that the sum of AP has got A's and D's in it. It certainly doesn't have any R's, so we want to get rid of the R's. We would also want to get rid of the D. But that's a little tricky to do at the moment. We've got 2 equations, 3 unknowns. We can't get rid of 2 things, but we can get rid of 1 thing. And let's make R our priority. So if we take the first equation, we could rearrange that to R squared is equal to A plus D divided by A. And then if we square it, we'll have R to the 4. And so we have R to the 4, so I can substitute it into the other equation. It's going to be A plus D squared over A squared. So if we substitute the R4 in to our other equation, we're going to get A multiplied by, I don't need a big bracket, A plus D squared divided by A squared, and that's going to equal A plus 5D. Okay, the A squared cancels with the A, and we're just left with the A. We can take the other remaining A up to the other side and get A squared plus 5AD, and we can expand the brackets as well. So we will get A squared plus 2AD plus D squared is equal to A squared plus 5AD. Okay, there's an A squared on both sides, so why don't we subtract A squared from both sides, and let's bring everything on the, well, let's bring the 5AD over. And so we will end up with D squared minus, we got 2AD minus 5AD is going to turn into minus 3AD is equal to 0. All right, we should think again. Now, because we're trying to find the sum in terms of A, that means we shouldn't be using a D in our sum, which means we should say D equals something. All right, can we arrange this so it says D equals something in terms of A? Well, yes, I think we can. And to do that, let's take that 3AD back over. We should probably have left it there. 3AD, and then of course we can hopefully see that D is 3A. We can divide both sides by D for that to happen. So D is equal to 3A, and A is A. All right, so that helps us now. We can do the sum of the AP of the first 20 terms, and of course the sum of an AP is equal to n on 2 times A plus n minus 1, so it's going to be 19, times D, but in this case, we are using 3A instead of D. And that is the sum of the first 20 terms in terms of A. We should just simplify it to make it look a little nicer. So we will get 2 on 20 is 10, and we have 2A plus 3 times 19 is 57A. 57A plus 2A is 59A, times it by 10, and we get 590A. And that should be our answer. Express 2x squared minus 8x plus 14 in the form to open the first brackets, x minus a squared plus b, close the first brackets. Well, the outside brackets and the inside brackets. That's not the normal form that we have for the turning point form of a quadratic. And so if we pay careful attention to that, we'll go, oh, but we can still make it look like that, right? So we are completing the square, and we're just not going to make it the normal turning point form. So let's start with, well, what we have, 2x squared minus 8x plus 14, and factorize the 2 out because, well, there is a 2 outside of all the brackets, right? Let's use square brackets because they did that. And we're going to be left with x squared minus 4x plus 7. Okay, so all we have to do is complete the square inside the square bracket, and we're done. So this is going to equal minus the 4x. I always like to put it in brackets half of the b, the negative 4, and square it. And then, of course, you can't just magically add things, so we have to subtract the 4. So I don't put it in brackets anymore. And the plus 7 is still there. Okay, I think one more line is all we need. The x squared minus 4x plus negative 2, and there was a reason why I left it like that, because that brackets just come straight into our completed square, and we have negative 4 plus 7 turns into plus 3. If we want to be really nice, we can let the marker know that we found out A is 2 and B equals 3. The functions f and g are defined as follows. The function of x is x squared, x is real, and gx is 2x squared minus 8x plus 14. That's the function that we were just working with, that we kind of completed the square on, but it's multiplied by 2. All right, so B says, describe fully a sequence of transformations that maps the graph of y equals fx, which is just x squared, onto the graph of y equals gx, which is the one that we analyzed a little bit, making clear the order in which the transformations are applied. Okay, so we just have to think to work this one out. And if we look inside the square brackets that we just made, we've got a quadratic which is in turning point form. And so we could take the quadratic of x squared, which hopefully we know has a turning point at 0, 0, and is a smiley quadratic. And we can just say, well, we can shift that, translate that, so the turning point goes to 2, -3, because, oh, sorry, to +3, because the turning point of the x minus 2 squared plus 3 is at 2, +3. So that would be the first thing that we could do, and then that would transform x squared into what is inside the square brackets. And then what is happening to what's inside the square brackets is being multiplied by 2. So you're taking a whole function, multiplying it by 2, and that means the function is going to stretch, or it's going to dilate away from the x-axis. All the y values are going to get twice as large, or if they're negative, they're going to get twice as large in the negative direction. So we call that either a stretch or a dilation, away from the x-axis or in line with the y-axis by a factor of 2. All right, we have a diagram with a circle and a straight line, and we have the equations of both of those. The circle with the equation and the straight line with an equation are shown. The line intersects the circle at A and B, and the center of the circle is at C. Find by calculation the coordinates of A and B. If we look at the equation for the circle, we can identify the C is -1, 2, and you can read that straight away from the circle. Pay attention, and hopefully that will help later. All right, how do we find the intersection of a line and a circle? Well, we just say, well, what's the solution, simultaneous solution for two equations? And we're going to substitute the line into the circle and solve. That's it. All right, let's work on it. So let's take x plus 1 squared, and we're going to replace the y with 3x minus 20 minus 2 squared, and that equals 85. Now, for the sake of clarity, let's just simplify that slightly. X plus 1 squared plus 3x minus 22 squared is 85, and we need to expand both brackets. So we will expand the brackets, have x squared plus 2x plus 1 plus 9x squared. 3 times 22 is 66, times 2 is 132, and it's negative, so minus 132x, and negative 22 squared is 484, becomes positive, of course. And let's subtract the 85 and make it equal to 0. All right, combining like terms, we have x squared plus 9x squared becomes 10x squared. 2x minus 132x is minus 130x. 1 plus 484 is 485, minus 85 is just 400. Oh, that turned out nicely, and that equals 0. We can divide by 10, and we'll get x squared minus 13x plus 40 equals 0. Can we think of two things that multiply to 40 and have a difference of 13? 410, no, 5 eighths. Yeah, 5 eighths. -5, -8, add to -13, -5, -8, multiply to 40. And so we have x minus 5, x minus 8 equals 0. Therefore, x equals 5, or x equals 8. So we need to find the y values. We can use either equation, the circle or the line. Of course, we're going to use the line because it's much easier. Y is equal to 3 times the x. So for the first one, it's going to be 3 times 5, and then we subtract 20. Or for the second one, y is 3 times 8 minus 20. So y is 15 minus 20, -5, or y is 24 minus 20, 4. Okay, we just have to identify which point is which. Hopefully we know that point B is below the x-axis, so that's going to be the -5y, and point A is above, so that's going to be the 4y. And so for point A, we will say it's going to be 8 and 4, and for point B, we would say it is 5 and -5. Find an equation of the circle which has its center at C and for which the line with the equation y is 3x minus 20 is a tangent to the circle. Well, that's the line from the previous part of the question. If it's now a tangent, it means that the radius of the circle is going to be smaller. And that point, let's try and draw a circle. It's a great circle. That's a tangent now. It only touches that line once. And of course, the radius is going to be at 90 degrees. What else would we know about AB? We should hopefully realize that the point of the tangent is going to be halfway along AB. How would you understand that? It could be if you have the bisector of a chord, AB is a chord, and if we bisect it, the perpendicular goes through the center of the circle. And that would, of course, tell you that the center of the middle of AB is where the circle is now going to touch the line, because the tangent to the line is perpendicular to the radius of the circle. Okay, so how do we solve this? We find that point, and then we find the distance from C to that point, which is the new radius. We already know what the center is, and we can just write the equation. Right, so we start with the points A, B. This question is going to fall apart if you didn't actually find out what A and B are. The midpoint is equal to x1 plus x2, so we're going to have 8 plus 5 divided by 2, the middle of the x's and the middle of the y's. 4 plus -5 divided by 2, and that equals 8 plus 5 is 13. We divide it by 2, and we'll get 6.5. And for -5 is -1, divided by 2 is -1/2. Okay. And the center of the circle, let's just call it C, it is called C, is reading from the equation of the circle, -1 and 2. So we're trying to find the distance from C to M. That is going to be our new radius, which is the square root of x1 minus x2. Let's do -1 minus 6.5 squared plus y1 minus y2 squared. All right, let's make that a little nicer to look at. -1 minus 7.5, it's going to become positive, of course, and plus 2 plus 1 is just going to be 2.5 squared, and of course we still need to do the square root of that. And with the calculator, that's going to equal the square root of 62.5. We should leave it like that because that's the radius. And when we write the equation of the circle, we use r squared, so the square root is going to disappear. So it just makes a lot more sense to just leave it as it is. Right, so our circle is fairly easy to create now. We're going to take the equation that we started with for the other circle, because that has the center. And we're going to add our new radius, which is radius squared, 62.5, because it was square root of 62.5 and it equals r squared, and so that's just 62.5. Show that, okay, we've got a fraction with a lot of trig functions minus another fraction with a lot of trig functions is equivalent to a fraction with a trig function squared. Okay, so how do we do that? We take one side and we work with it until we get the other side. Which side should we take? Well, the more complicated side, the left side. And what should we start with? Making a single fraction by cross multiplication is definitely what we should start with. Left-hand side is equal to the sine theta plus 2 cos theta times cos of theta plus 2 sine theta minus cos of theta minus 2 sine theta times sine of theta minus 2 cos theta, all divided by cos theta minus sine 2 sine theta times cos theta plus 2 sine theta. So we just have to keep stepping through this. Right, sine times cos is sine theta cos theta. We have 2 cos theta is 2 cos squared, and we have 2 sine theta is 2 sine squared. And that's going to, well, let's simplify that. 2 cos squared plus 2 sine squared is just 2 times cos squared plus sine squared, which is 1, so it's just 2. We can write less by doing that. And then we have 2 cos times 2 sine turns into 4 sine cos. Subtract, because we're subtracting, let's leave the brackets there for a moment. Cos times sine is cos sine. We have minus 2 sine squared minus 2 cos squared is minus 2 sine squared plus cos squared in brackets if it was, which would just be negative 2, because that would become 1 as well. And then we have negative 2 cos theta times negative 2 sine theta is 4 cos theta sine theta. On the bottom we have a minus b times a plus b, so it's just a squared cos squared theta minus b squared theta, which is minus 4 sine squared theta. Right, we can see a few things are going to cancel here. On the top, sine squared theta, sine theta cos theta, sorry, plus 4 sine theta cos theta turns into 5 sine theta cos theta, plus the 2. Let's distribute the minus sign, but we can put the cos sign together with the 4 cos sign and turn it into 5 cos sign, make it negative, of course that minus sign comes in. The negative also comes into the negative 2, it makes it plus 2. And on the bottom, well, we're looking at the answer. We need to get to a cos squared on the denominator. So let's turn the sine squared into a cos squared. All right, and that's going to equal 4 over cos squared, expand the brackets, minus 4 plus 4 cos squared theta, which is our answer. So we should just write it. 4 over 5 cos squared theta minus 4. And if we want to be really good, we will say equals the right-hand side. Hence, solve the equation, that horrible thing that we got given equals 5. For 0 to 180 degrees. Okay, we're going to use what it transforms into, and that, of course, equals 5. So we have 4 over 5 cos squared theta minus 4 equals 5. Let's get rid of the, let's bring the denominator up to the other side. 5 5s, we have 25 cos squared theta minus 20. Okay, take the 20 over and we'll get 25 cos squared theta is 24. And so cos squared theta, 24 on 25, and cos theta is the square root of 24 on 25. Don't forget your plus or minus. So there's going to be 2 answers there. Do the inverse cos of square root of 24 on 25, and your calculator will tell you 11.53, round it to 1 decimal place, 11.5 degrees. Because the cos of the angle can be positive or negative, it can be in any quadrant. So it's 11.5 there, and we're allowed to use the second quadrant because we're between 0 and 180 degrees. So our second answer will be 180 minus 11.5, which is approximately 168.5 degrees. The front of the paper says give angles in degrees to 1 decimal place, so that's exactly what we will do. The diagram shows the circle with the equation x minus 2 squared plus y squared is 8. The chord AB of the circle intersects the positive y-axis at A and is parallel to the x-axis. find by calculation the coordinates of A and B. Well, A is on the y-axis, so that's where x equals 0. So to find A, we take the equation of the circle and make x 0. So we'll have 0 minus 2 squared plus y squared is 8. Negative 2 squared is 4, and if we take the 4 over to the other side, we'll get y squared is equal to 4, and y is plus or minus 2. All right, if we look at the diagram, it makes sense because A will be plus 2, and the other part of the circle that crosses the y-axis will be at negative 2. All right, so maybe we should note that A, the coordinates of A are going to be 0 and positive 2, not negative 2. Then to find B, we can take the y value, which we now know for B and A are the same. The y value is 2, put it into the equation, and we will have x minus 2 squared plus 2 squared, because y is 2, is equal to 8. 2 squared is 4, 8 minus 4 is, 8 minus 4 is 4. And so we're doing the square root of 4 again. And so we have x minus 2 is equal to plus or minus the square root of 4, which is plus or minus 2. So x is going to equal negative 2 plus 2, which is 0. We already know that. Or x is going to equal positive 2 plus 2, which is 4. Right, that tells us that the coordinates of B is going to be 4, 2. I think it's fairly clear what our answers are, but just in case the person marking it likes to see the answers at the end of the problem, we'll just add them here. Would they be that pedantic? We don't know. Find the volume of revolution when the shaded segment, bounded by the circle and the chord, is rotated through 360 degrees around the x-axis. Okay, so if we just rotated the circle around the x-axis, it's going to rotate the part all the way down to the axis, but we have to cut that part out. So we've got two options. We can cut it out by subtracting the equation of the chord from the equation of the circle, or we can cut it out by doing the volume under the circle and then subtracting from that the volume of a cylinder that would represent what the chord equals. Let's try the integration. So do we remember that volume of revolution, let's do VOR, is equal to, we're going to integrate from one x value to another. Let's go A to B. Integrating along the x-axis, and it's going to be pi, or a bunch of circles, pi r squared, but in this case r is y, because it goes from the x-axis to the equation, y squared, and we'll go along the x-axis, so it is dx. So volume of revolution around the x-axis looks like that. For our function, it's going to be the integral from 0 to 4 of pi. We can do a simple rearranging of the circle equation to replace the y squared. Y squared is going to equal 8 minus x minus 2 squared. So we should put that in brackets because that's the whole of y squared. So it's going to be 8 minus x minus 2 squared, close brackets, dx. Okay, we need to subtract the cylinder, but we could actually do that with integration as well, and we would integrate from 0 to 4 again, and in this time it's still going to be pi and the y squared, but the function is y equals 2, and so we would just say 2 squared, which is 4, and say dx. If you have two integrals that are going from the same boundaries, they can actually be compressed into one integration. And we can do a little bit of manipulation here. There is a pi in both of those, so why don't we take the pi out the front and make our life even easier. So we have 0 to 4. On the first one, we now have 8 minus x minus 2 squared. And on the second one, we have minus 4, because we've already taken the pi out, and we have dx. Okay, we're doing quite well. We can simplify 8 minus 4 to just be 4, and then we can do an integration. So pi integral from 0 to 4 of 4 minus, we can leave this in the power form and integrate by using the chain rule. All right, so this is going to equal pi, gets to stay out the front. And our integration is 4 came from 4x. The brackets for the chain rule would stay the same, so it's going to be x minus 2, but raised to the power of 3 now. If you differentiate what's inside the brackets, x minus 2 would put a 1 out the front, so that doesn't do anything. And the 3 we need to get rid of the 3 that would come down, so we need to put a third out the front. And we're going from 0 to 4. Okay, let's put in our values. So we have pi, if we put in 4, and let's work out what we can. 4 4s are 16, minus 4 minus 2 is 2, and 2 cubed is 8, minus 8 on 3. And we're going to subtract, so I better put another bracket there. Put 0 in, and we'll get 0. 0 minus 2 is negative 2. Cube it, you get negative 8. So it's going to be cancelling the minus sign out the front, and we'll get minus 8 on, or plus 8 on 3. But we're subtracting, so we've got 2 8s on 3s. We will just get 32 on 3, 16 minus 16 on 3. And that's times pi. So 32 pi on 3. It's a fairly good answer, but maybe they would like a decimal. That will be approximately 33.5 rounded to 3 significant figures. Question 9, we have 3 functions, f, g, and h, and their definitions. Part A, we need to solve the equation, the function f equals 0, and give our solutions in a form. Oh, so it's in the exact form. And A, B, and C are all integers. Okay, so all we have to do is take the function and make it equal to 0. So it sounds easy, right? So we say x minus 4, x to the half is root x, plus 1 equals 0. Oh, if you look at that, hopefully you recognize that's a quadratic, where the variable is the root x, and the squared term, of course, just becomes x. So what multiplies to 1 adds to negative 4? Oh, we don't know. So we're going to use the quadratic formula. And remember, the variable is root x, so we should probably say that root of x is negative b, which is just 4, plus or minus the square root of b squared, 16, minus 4ac, 4 times 1 times 1, over 2a over 2. Okay, that is going to equal 4 plus or minus root 12 over 2. All right, so we need to know our third rule. So root 12 can be root 4 times root 3, and we can do the square root of 4, so it comes out, and it will become 4 plus or minus 2 root 3 over 2, which means that the 2 can cancel, and we will have 2 plus or minus root 3. That's the square root of x. We need to find x, so x is going to equal that squared. So x is going to equal 2 plus root 3 squared, or x is going to equal 2 minus root 3 squared. Okay, so the first case, x is going to be 2 squared, which is 4, 2ab plus 4 root 3. B squared is root 3 squared, which is just 3. Or x is going to equal, again, 4 minus 2ab, 2 2s are 4, root 3, and negative times a negative is positive, and root times a root is just the value. There's our answer. X is equal to 7 plus 4 root 3, or X is going to equal 7 minus 4 root 3. Given that the function f is equal to g(hx), find the values of m and n. Right, well, our function x is, as we know, x minus 4 root x plus 1, and it's going to equal, we have to put h into g, and so we're going to have m, and instead of x, we're going to put root x minus 2 squared and plus m. Well, let's expand the brackets. A plus b squared is a squared, so that's just going to be x plus 2ab minus 4 root x plus b squared plus 4 plus n. Well, that looks very similar to what we have. What can we do? Oh, we can just expand it and just get mx minus 4m root x plus 4m plus n. All right, well, we have a quadratic with x and root x. We have another quadratic with x and root x. So the coefficients have to be the same. This is the constant at the end. Coefficient of x is m, and the coefficient of this one is 1, which means that m has to equal 1. All right, if m equals 1, does the second one work? Minus 4m equals minus 4, yes it does. And so if m equals 1, then we know that 4 plus n, 4 times 1, plus n is equal to 1, and so n is equal to -3. I think we're done. So the diagram shows a circle with A radius 5, circle with B radius 8. The circles touch at C. ACB is a straight line. The tangent at the point D on the small circle, so it's 90 degrees to the radius, intersects a larger one at E and passes through B. Find the perimeter of the shaded region. Okay, so straight away we can add in, that's going to be 5, that's going to be 8 because it's the radius, that's EB. On the triangle at the bottom, 5 plus 8 is 13, so we have 13 there. Oh, that's a Pythagorean triad, 5, 12, 13. But let's say you didn't know that. Now, to find the perimeter of the shaded area, we're going to need to do the arc length. So we're going to need the angle there, and we're going to also need that angle so we can find the two arc lengths in radians, right? And then we can find DE. Pythagoras' theorem minus the 8 for the side. That's our process. Let's do it. So from the triangle, we have 5 squared plus dB squared is equal to 13 squared. So dB, if you know your triads, it's 12. But let's say we didn't know it, you would do the square root of 13 squared minus 5 squared, put it in the calculator, and you'll get 12. Which means that DE is equal to 12 minus 8. So DE is 4. So we found part of the circumference, we found the length of DE. Let's find the arc DC. To do that, we need the angle DAC. And the angle DAC, well, cos of the angle is going to be 5 on 13. So the angle, oh, that's a terrible angle. DAC is going to be the inverse cos of 5 on 13. Right. Put your calculator in, radians mode, and we will get 1.176 radians. Okay, store it on your calculator so you can use the exact value. And let's find, we can find the arc length. Let's do that. So DC is going to equal r theta, which is going to be 5 times 1.176. So arc of DC is approximately 5.88. Let's 8800, which is kind of handy for us. 002. Moving on, we need arc length EC. So we're going to find angle EBC. We could 90. We could subtract what our previous angle from pi on 2. That's 90 degrees. To find the angle, or we could do sine, whichever you like, as you wish. So the inverse sine of 5 on 13 is going to be our angle, and use a calculator, we'll get 0.3948. Okay. Once we know the angle, we can find out the length of the arc CE quite easily. R theta, which is going to be 8 times that. All right, let's write it. 8 times 0.3948, which equals approximately 3.158. So our perimeter is going to equal the straight length, which is 4, plus the length that we just found, 5.8800 plus 3.158. I highly recommend you use exact values. When you do, store your values on your calculator and you'll get 13.03835. All right, the paper does say give our answers to 3 significant figures, so it's going to be 13.0. Maybe you don't need to store the exact values, but you want to have like 5 significant figures so you don't make an error in your final value. That's the perimeter. We're done. Puppy, find the area of the shaded region. Okay, we should recognize that the shaded region is the area of the triangle minus the area of the 2 sectors which are inside of the triangle. So that's all we have to do. The area, do we want to do it in one line or multiple lines? Okay, let's do it in one line. The area is the triangle, half base height minus a sector of a circle, half r squared theta, in radians of course, minus the other sector, half r squared theta. That's fun, isn't it? So it's a half of 5 times 12 minus a half of the radius, which is 5 squared, multiplied by the angle in radians, 1.176, minus a half of 8 squared radius, times the angle, which was 0 in radians, of course, 3948. Okay, I've stored those values on my calculator, so I'm going to use the exact values for the angles, put it all in the calculator, and get the area. And the answer is 2.666619. Right, as instructed on the front. Let's round to 3 significant figures, 2.67. Let's put approximately. And we do have units, so we can actually say centimeters squared. It's given that a curve has the equation y is k, 3x minus k to the minus 1 plus 3x, where k is a constant. Find in terms of k the value of x at which there is a stationary point. Right, so for a stationary point, we know that the derivative is 0. So we need to find the derivative to find a stationary point. So dy dx, because they gave us a y, is going to equal, let's differentiate this. Using the chain rule, the bracket stays the same. So we'll have 3x minus k, and we need to subtract 1. So that's going to become negative 2. All right, what happens when we differentiate? Well, you differentiate what's inside the brackets. You get a 3. It comes out the front. and the -1 should have come out the front before we subtracted 1. So let's take -1 and 3 out, and we'll get -3k, which is out the front. Should have left a little more room. And if you differentiate 3x, you just get 3. Okay, I think we're pretty good. So when does the derivative equal 0? Well, when we have minus 3k over 3x minus k squared plus 3 equals 0. All right, so what are we going to do? Let's take the 3 over to the other side, make it negative, and then multiply by the bottom of the fraction. So we will get minus 3k is equal to -3, although you're going to cancel, 3x minus k squared. Okay, what are we trying to find? We're trying to find what x is in terms of k. So we have to rearrange that to say x equals something. Divide both sides by -3 and then take the square root of both sides, and we will get 3x minus k is equal to the square root of k. I got a feeling maybe we should put a plus or minus there for the square root of k. So we can find out what x is pretty easily now. Let's add k to both sides. 3x is k plus or minus root k, and then x is that divided by 3. X is k plus or minus root k over 3. The function f has a stationary value at x equals a. So a is the x value. And it's defined by function x is 4, 3x minus 4 to the minus 1 plus 3x. X is greater than or equal to 3 on 2. Find the value of a and determine the nature of the stationary value. Isn't that just the function we just did? Instead of k, they put a 4. And didn't we just find the stationary value for that function? Where instead of k now we have a 4. So can't we just say the x value, or which is in this case the a value, a is going to equal 4 plus or minus square root of 4 over 3. I'm sure we can do that. So therefore, a is going to equal 4 plus, root 4 is 2, of course, and 4 plus 2, 4 plus 2 is 6, divided by 3 is 2, or a is 4 minus 2, which is 2, divided by 3 is 2 on 3. X, we're told, is larger than 3 on 2. 3 on 2 is 1.5, so you can't equal the 2 on 3. Can't be an answer because it's smaller than the domain for x. Okay, so there's only one answer. A equals 2, and we need to find the nature of this stationary value. To do that, we should differentiate the function twice and put the value in, or we can put the value on either side of 2 into the first derivative and work it out that way. Because we already did the derivative before, but with k, we can just take the work that we did and replace the k with our 4, because we know that k became a 4. Right, so the first derivative is going to be minus 3k, which is now minus 12, and we've got 3x minus k, which is minus 4, and that was to the -2, and we had a plus 3 on the end of it. Okay, so then the second derivative, f dash dash x, is equal to, I'm going to leave a little more space this time. The brackets, because it's the chain rule, will stay the same. Minus 4, and we subtract 1. We will subtract 1 later. But first, the -2 comes down, and so we'll take the -2. We're going to multiply it by the 12. That's already there. The 3 comes out. We differentiate what's in the brackets. It becomes 3. And we multiply by that, and we multiply by the -12, which is already there. Then we subtract 1 from the power, just so we don't get confused. And of course, when you differentiate 3, you get nothing. All right, so this is going to equal 6 times 12. So positive 72 over 3x minus 4 cubed. When we have the value of 2 for x, which is our stationary point, we're going to have on the bottom 3 times 2 is 6, 6 minus 4 is 2, it's positive, the top's positive, so it's going to be positive. Okay, therefore the stationary point is going to be a minimum. I think we're done. The value of a and the nature of the stationary point. All right, and the last question, the function g is defined by gx is negative 3x plus 1 to the negative 1 plus 3x, which is very familiar. It's related to the first part. Determine, making your reasoning clear, whether g is an increasing function, a decreasing function, or neither. Okay, so increasing, decreasing, it's talking about the gradient. If the gradient is positive, it's increasing. Gradient is negative, it's decreasing. If the gradient's horizontal, it's neither. It's increasing or decreasing. That is like the first function that we did, but what is k this time? K is negative 1, because it was k times the 3x minus k. And so if k is negative 1, we actually have the function, which means we've already done the differentiation for it. We just have to replace our differentiation with negative 1 for k. And so that's going to be 3x plus 1 to the negative 2 plus 3. Okay, so our differentiation is 3 over 3x plus 1 squared plus 3. We can make a definitive claim that the derivative is always going to be positive because of that squared value there. 3 divided by a positive is a positive, plus a positive is always positive, which means it's an increasing function. So we should write as 3x plus 1 to the power of 2 is always positive. The derivative g dash x is greater than 0, which means that gx is an increasing function.